Let's dive right into this explainer because today we're tackling the absolute biggest bottleneck in India's EV revolution. We're talking about scaling up battery production. We're getting an exclusive look inside Amara Raja Advanced Cell Technologies, and man, their mission to build the future of energy storage is nothing short of massive.
Here's how we're going to decode this operation. First, the EV battery scale-up. Then we'll look at the pilot line leader role, check out the manufacturing process, open up the quality toolkit, explore the core responsibilities, and wrap it all up with, are you the one?
Section 1, the EV battery scale-up. So our journey actually starts in Shamshabad, Telangana, right inside the E+ Energy Labs. This is where Amara is literally pushing the boundaries of what energy storage tech can do.
But here is the company's ultimate macro challenge. They have to bridge a massive, and I mean literally massive, manufacturing chasm, moving from a megawatt-hour scale pilot line to a full-blown gigawatt-hour scale commercial gigafactory. That isn't just a step up, it's a complete transformation. You are completely reinventing your infrastructure and precision.
Section 2, the pilot line leader. To actually make this crazy leap, they need a very specific kind of commander at the helm. Specifically, a head of Lion pilot line manufacturing.
Now, let's be crystal clear here. This is a senior role that demands an absolute veteran. We are talking over 20 years of dedicated lithium-ion manufacturing experience. Why so much? Well, as you probably know, battery chemistry at this scale is notoriously volatile. Freshers absolutely need not apply here. They need someone who has lived, breathed, and practically slept on the factory floor for decades.
Section 3, mastering the manufacturing process. Let's break down the actual physical battlefield. This is the complex, multi-stage process that this leader has to intimately oversee and, honestly, perfect.
So, phase 1 is electrode preparation. This is a beast of a process with 5 highly precise stages. It kicks off with slurry mixing, getting those raw materials perfectly combined. Then, electrode coating, which means applying that slurry with just absolute pinpoint precision. After that, we've got drying, followed by calendaring, which compresses the materials, and finally slitting, where those coated electrodes are sliced down to exact dimensions. Then we hit phase 2, cell assembly. This is where you take those pristine electrodes and run them through cell stacking or winding. Next up is welding to lock in those connections right into cell encasing to protect the whole package. Then comes the incredibly delicate process of electrolyte filling, and finally, cell formation. This is the magic moment. The crucial stage where the newly assembled cell is essentially brought to life and takes its very first charge.
Section 4, the manufacturing quality toolkit. Okay, managing those 10 steps in a lab environment, that's one thing. But how on earth does one person ensure flawless quality when you are pumping these out at a massive gigawatt scale?
Well, they rely on a seriously heavy-hitting toolkit. This leader has to deploy continuous improvement methodologies like lean manufacturing and Six Sigma. Armed with 8D problem-solving and DMIAC, they are basically on a relentless hunt for root causes, snuffing out defects before they can even think about multiplying on the line.
Let's take a second to demystify some of these technological acronyms this leader has to master. First up is MES, the Manufacturing Execution System. You can think of this as the digital brain of the whole operation. It is constantly tracking and managing the entire factory floor's production, completely in real time.
Next is SCADA. That stands for Supervisory Control and Data Acquisition. This is the lifeblood of their industrial automation. It feeds them the high-volume data streams and gives the direct control you absolutely have to safely and efficiently run machinery at that massive gigawatt-hour scale we talked about earlier.
Then we've got PFMEA, Process Failure Mode and Effects Analysis. Using this methodology is, well, it's basically playing 4D chess with the manufacturing line. You have to predict, assess, and prevent potential risks and process failures long before a single bad battery cell ever sees the light of day.
And finally, SPC, Statistical Process Control. This is what ensures that through rigorous statistical monitoring, every single step of the process stays perfectly stable. It's the ultimate guarantee that every single battery rolling off that line meets exact, completely uncompromising quality standards.
Section 5, Responsibilities and Core Focus. So you combine that incredibly intricate 10-step process with this advanced engineering toolkit, and you really start to get a feel for the intense, day-to-day pressure of this role.
The responsibilities here are just immense. I mean, they aren't just managing the pilot line.
They are building high-performing teams, constantly improving process efficiency, aggressively reducing defects, enforcing safety compliance, and ultimately shouldering that monumental scale-up to commercial manufacturing.
But the crucial point here, the real bottom line, is how success is measured. They have to drive higher production output and better manufacturing yield, all while completely mastering OEE, overall equipment effectiveness. You basically have to maximize productivity without sacrificing a single microscopic drop of product quality.
Section 6. Are you the one? If you are listening to this explainer right now and thinking, you know what, this high-stakes technical mission sounds exactly like my calling, well, let's take a look at the precise credentials they are hunting for.
Because battery manufacturing is this insanely complex chemical and mechanical operation, Amara Raja needs highly educated candidates. You're going to need a bachelor's, a master's, or a PhD. And they have a really strong preference for degrees in chemical engineering, materials engineering, mechanical engineering, or, a very closely related discipline.
If you've got the advanced degree, that unparalleled problem-solving ability, the team management chops, and of course, those 20-plus years of hard-fought lithium-ion manufacturing experience, well, you can submit your profile directly to pk23@almaraja.com.
Breaking down just this one single role gives us such an incredible window into the sheer complexity of the energy transition. It really leaves us with a fascinating final thought to chew on. What kind of incredible engineering, leadership, precision, and massive scale is it actually going to take to permanently shift our entire transportation grid over to electric power? It's an absolutely massive challenge. And the coolest part, it's happening right now.